This is the W0IVJ Rotator project. The rotator can be seen on the left and the control box on the right hand side. The rotator consists of a worm gear drive situation, which is self-braking, and it's controlled by a Ford F-150 wiper motor. The gears inside the rotator are replacement gears for a winch. This is a closer view of the rotator. You can see the motor on the left hand side, and you can see the rotator rotate when the control box activates it. You can see the top part rotating there. Probably hear the sound. This is a shot of the rotator with the cowling off. The cowling, by the way, is made of gutter material before it's formed. It comes in a nice strip that you can cut to fit, and it's the right thickness, and it's already powder coated. I'm going to turn the rotator so you can see the worm gear operate. The green thing over to the right is the pot that keeps track of the direction. I'll go ahead and swing this around a little bit so you can get a better view of the pot. That black Delrin gear is not too visible because it's so dark in there. You can also see a little bit of the ring gear with this shot. This is a close-up of the worm gear and also of the pot and its gear. The pot is used for telling the direction of the rotator. It is a 10-turn pot, and it allows 540 degrees of complete rotation. We'll get into that a little bit more when we start talking about the control box. But to see this operate, I will activate it. You can see the auxiliary gears off the worm driving the worm gear, and you can see the gear driving the pot. So that's how it works. There is a bearing up at the top. This is a bearing right up here that takes the sideways thrust, and it is a roller bearing. There's also a bearing at the bottom that's a thrust bearing and a sideways bearing. So there's two roller type bearings in this rotator. Taking a closer look at the control box, you can see that we have a knob right here. It can dial in the direction that the rotator wants to go. This is sort of like a compass rose here with east, north, west, and south at the bottom. Also, you have a target position and an actual position. Those are in degrees. And then the sliding scale on the bottom right here shows where the rotator actually is. In order to turn the rotator in a direction, you simply grab the knob, turn it like this, push the start button, and you can see that now the target position was indicated, and the actual position is tracking to the target position. When the actual position is reached, the target position goes to dashes, so there's no confusion. You can also see the sliding scale on the bottom here. Let me do this again, and you can see that we're sliding from north toward west, and the dial indicator indicates that. Now, when you move the rotator, let me move this just a little bit south of east. You can see that the rotator dial is going over toward on one edge. This rotator will do 540 degrees full rotation, and in order to avoid wrapping the feed line and the control lines around the mast, the rotator needs to be smart enough so that it doesn't rotate too far. You can see that if we wanted to rotate a little bit east of north, like this, that the shortest distance as it appears here would be only maybe 90 degrees or so. But You can also see that the rotator is over at the end at this point. So when I punch this button, the rotator now, instead of rotating in the direction that you would think, it realizes that it would be at the end of its rotation, and so it's rotating back the other way. It's going to come back through west, through north, and toward east to get there. The rotator controller is smart enough to realize this and keeps the feed line and the control lines from wrapping around. Now, the other feature of the rotator controller is that if you are in the middle of a rotation and you change your mind, as soon as you turn the knob, the rotator will immediately stop and go into the indicating mode on the target, so you can select a new target and move to it. So you don't have to complete a rotation once you start it. Also, if you listen very, very carefully, you can hear the ramp start and the ramp stop on the rotator motor. This is to avoid unusual acceleration and deacceleration on the antenna. Listen carefully and you can hear the stutter start and the stutter stop. Okay, here's the stutter start and the stutter stop. One other feature of the IVJ rotator controller is an overcurrent capability. I have recompiled the code that goes into the microprocessor, and I have set the current limit very, very low to simulate this. So when you try to rotate, and if you have a overcurrent situation, this is what happens. You can see that the screen immediately starts blinking and gives a message of overcurrent, correct the fault, turn the power off, and turn the power back on. Those are the steps that need to be followed. First, you correct the overcurrent situation, or you have an indication of the overcurrent situation. You correct the fault, and then you turn the power back on like this, and you're set to go again. I'm now going to rotate the rotator around a large distance. I have a piece of black tape that is pointed to the west. West is to the left of me, and you'll see the piece of tape come around to the south as it rotates. The target is 300 degrees, which is to the northwest, so this should be almost a full rotation. Coming around to the east now. Now coming around to the northeast on the back side. Now it's coming around to the north. And it should stop at the northwest. Now I'm going to rotate a little bit south of east. And it's coming on around the same direction, as you can see. So you can see that it certainly has more than 360 degrees of revolution. In fact, it's got 90 degrees on each side, which gives it 540 total.